So here we're going to start off with the equations and inequalities. So the first thing you need to know is the golden rule, the algebra's golden rule. And it says, learn the golden rule. You must learn this golden rule. The first step to solving for x is going to be getting x alone on one side of the equation and everything else on the other side, right? Remember the algebraic golden rule. What you do to one side of the equation, you must do to the other side. That's how the equation stays equal, right? So that is a very golden rule, and you must always have in mind that whatever you do to the equation, am I doing something that is going to make it balance or not balance? Okay, so am I doing what I've done on the left hand side, have I done to the right hand side? So the general steps for solving equations are expanding all the brackets, rearranging the terms, group the like terms together and simplify, factorize if necessary, find the solution, and check the answer by substitution, right? So here you must remember an equation must always be balanced, right? Whatever you do to the left hand side, you must also do to the right hand side. And it's absolutely important because it is the golden rule. Now, here's the first example. And the first example, as you can see, we have solve for x, where it says 4 multiply all into the bracket 2x minus 9, and outside of the bracket minus 4x is equals to 4 minus 6x. And when you solve this, you use your algebraic rules that you know, like simplification for instance, where you take 4 and you multiply it inside. Why? Because it's distribution, or also known as the FOIL method, and you find your answer. And then you start using you're grouping the like terms, right? And you group your like terms, and as you can see here, I have 4x plus 6x, and I have 4 plus 36 on the other side. And then you find that you get your answer, which is 40, and then you divide it by 10. Remember, you are looking for x, not 10x. So you have to divide 10 to make it into an x. So it's 4x right there. And then we move on to the next example, where it says solve for a. Now remember, solving for x doesn't necessarily mean we cannot change the variable, because remember, x is a variable, and a variable means it is something that is unknown. It is just the number that is unknown. You're just writing x because you don't know the number. Just like if I would write a g in place of x, it's still a variable because I still don't know what the answer is. So it's the same thing. So here we just used a, and it's still the same idea, and you just go ahead and solve. So here we have 2a minus 3, or divided by 3 minus 3a is equals to a divided by 3. And so the first step that I applied, I multiplied on both sides. Remember the golden rule? I multiplied on both sides. Why? So I know that 3 will cancel out with 3, and I'll be left with 2a minus 3. And also, if I say 3 multiplied by minus 3, it will give me 9, right? And remember, I did FOIL method. I did the FOIL method, or distribution. And here as well, 3 will cancel out with the other 3, and I'll be left with a. And then it's quite simple from there. I group the like terms, and I find my final answer, which is minus 3 over 8. Okay, so that is that example. Now, we move on to the method for solving quadratic equations. Now, in quadratic equations, you would see that you must rewrite the equation into the standard form, right, where you have x squared plus an x and plus a c, right? And then you divide, make sure that you can try and get it into the simplest form as possible, far as possible. And so then you can factorize. Once you factorized it, it has to be in 2 brackets because it is a quadratic. And then once you get there, step 4 is that the 2 solutions are obtained by allowing that the first bracket equals to 0, and then that you'll solve, and you'll find that is actually something like that. and then also with the other bracket it will also yield you something like that. Okay, so let's just do an example. So here's the first example over here, and so the first example is 3x squared plus 2x plus 1 is equals to 0. So we already have it in its simplest form, where it is a in its general form, which is this one, which is ax squared plus bx plus c. But now the problem here is that we cannot actually divide through, because then we'll be working with fractions. And you know how difficult it is to work with fractions, especially when you have to figure out the factors of that fraction. Okay, so what do? We keep the 3, and we realize that in actual fact it is 3x minus 1 and x minus 1. And how do you know that this is correct? You know that this is correct because if you check it by using the FOIL method, you will arrive to your original quadratic, and then you use the equation, and then you find your final answers, which is 1 over 3 and 1. Now, another important thing, we always say it's or, because or means that it is either that one of the two, if x is equal to one of the two at any moment, if it's equals to 1 or it's equals to 1 over 3, it will give you this equation to be equals to 0. Okay, so don't get confused and start writing and. Okay, it is a big mistake. Okay, so simultaneous equations. This is quite interesting. So when solving for two unknown variables, two equations are required, and these equations are known as simultaneous equations. And basically, in simultaneous equations in general, if there are n unknown variables, then n independent equations are required to obtain a value for each of the n variables. And basically, this is what we have here. So the first example, we have x plus y is equals to minus 1, and y minus 2x is equals to 3. And basically, I just want to illustrate to you what's basically happening. So here are the equations, or here is the graph, the graphs of these two equations. So they are crossing each other at some point. But you can see on the graph that it's actually close to -1. But it's definitely not -2. It's somewhere close to -1. But also here you can see it's also less than 1 for y. So let's see if you can find this answer. Okay, so here is the method. You can just stop the video and look at it, but I'll go to the example now. So the example here, what we do is we name the first equation as equation 1. This is very important. Name the equations as equation 1 and the equation 2. And then the second thing is to let equation 1, or the easiest equation. So I saw x plus y as the easiest equation. So I took x plus y and rewrote it as x, as a single variable on one side and everything else on the other side. And then I resubstitute, and then I substitute it into 2. So I take what I wrote on the other side in place of x. In the place of x here, I write what I had rewritten it as. So it's -1 minus y. And then I solve it as a normally solve for x or equation, and I find my answer is 1 over 3. And then I take my answer 1 over 3, and then I resubstitute it into the equation that I started with, which is the first one. And then I get my final answer, which is -4 over 3. And then that's it. So there are two methods. This method is called the substitution method because I substituted another equation into another. Substituted one equation into the other. And then we have the elimination method. Now the elimination method is quite tricky, so I do advise you, if you do not understand the elimination method, please stick to substitution, because substitution will always work. But with elimination, there are times where it will fail you. Okay, so here you still do the same thing. You name the equations, and then you can see that here I say, no, I would like to make the equations subtract each other, and once they subtract each other, I find that this gives me negative 3 over 4 and 1 over 3, and that is our answers. But the key thing here is that you need, for elimination to work, you need to have in both equations a variable that is the same. Okay, so that is the key thing, and that is why I say, if you do not understand how to use elimination, please don't. Okay, and then inequalities. And then with inequalities, I'm just basically the difference between inequalities and equations is that inequalities give us a range of values, an interval of values, and as you can see here, these are the examples of that, right? Now, here is the first one here, and I'll just go straight to the answer where it says it's from negative infinity to 4. So the answer for this particular equation is that r is less than 4, but that means that it is not included. We're not including 4, but we're including every single number all the way to negative infinity. But we're not including negative infinity because we can't include negative infinity, because infinity is just a number that is just growing and growing and growing. So here again we have a double-sided inequality, and a double-sided inequality is basically that when you subtract 3 here, you also subtract 3 on both sides, and then you find your answer. And then as you can see, this inequality signs means that it is including 2. So when you write your number line, you must make a closed um, a black dot where you put all the color in, and then when it is just an equality where it's just greater than or less than, then it is an open dot. Okay, and then when you write it in interval notation, you find that it is a square bracket to mean that it's including 2, and then when it's not including 2, it is an open bracket. And then here we just have the final thing where it is the graphical representation of example 1 and 2. So the answer for 1 and 2, if you had to see it on a graph, would be this. And as you can see, you have a broken line, meaning that it is less than, meaning at 4 we're not including it, but everything else is included. And then also here you can see the same thing. Here on the left hand side, you can see that it is actually not a broken line, and that means that it is included, 2 is included. So that is it for today, and I hope this was helpful. And try and relook at the methods, and thank you and good luck.